do the video for the tutorial 1 part 2 lah. Okay, and then maybe you can watch on the Friday lah. So because on the Thursday we are holiday. Alright, so because of the not our Ramadan, it's the Melaka historical day. Right, so next week is no class on the Thursday. So maybe on the Friday we just do the asynchronous method lah. That means I will give the link. I will share the link for the video, and then you can see the video lah. You can watch the video. So I think maybe next week we focus on the tutorial 1 part 2 lah. Alright, so now will be 4 minutes. Okay, so you have 25. Okay, I think better we can start lah. We can start our lecture for today. So today we go for the new chapter. It's a chapter 2. Okay, chapter 2 is the logic gates and Boolean algebra. So I'm not sure. So maybe before this, I'm not sure you are study about the logic gate or not. Okay, maybe you can see the Boolean algebra. I think on the mathematical subject you already study about the algebra, or we call the Boolean algebra. Okay, just maybe refresh maybe refresh what is the logic gate, what is the Boolean algebra. Right, so maybe you can I'm not sure, so maybe before this you see this one. Right, so we have the logic gate here. Alright, so do you know what is the logic gate here? What is the logic gate here? Okay, this is for experiment, don't worry. After that we go one by one. So this is some basic logic gate. Just refreshment. Maybe some of you background electricals in the vocational school. So maybe you are study about the some logic gates. So this one is maybe some of you know. Okay, and everybody know this one is what we call this logic gate. So this one we call the not, or sometimes we call the inverter lah. Okay, so this is a basic the basic logic gate. Or we have another one here. So this one we call the AND gate. Okay, just the refreshment. I'm not sure. Maybe on the physics or on your multiplicity. So you study about this logic gate, the basic logic gate. So this is we call the AND gates. All right. So another one, the basic one, we have we call the OR gate. Okay, this is OR gate. Okay, this is a NOT, or sometimes we call the inverter, or sometimes we call the complement. Okay, and then another one we have the AND gate. Okay, actually this is 3 basic gate lah. So we have another one is the combination between 2 gates. For example, we have the we have the Nand Gate or exclusive OR. Okay, exclusive OR gate. Okay, we have the exclusive. Okay, and then we have the Nand Gate. This one we call the Nand Gate, and we have the NOR Gate. Okay, this one for example, this one we call the NOR Gate. All right, so this one we can Nand Gate. This means combination between the AND gate and not inverter. So combination in this one is the AND gate and combined with inverter here. Actually, so you can separate by 2 like this one. So we have the OR gate here. Then we have the inverter here. So this one will be like we call the NOR gate. So it will be like this one. Actually, this NOR gate is a combination between the OR gate and not gate so or we call it inverter. So for example, for input, so for NOTs, for example, we have the 1 here. So automatically we know, so the output will be 0. The output will be 0. That means will be invert the inputs. Okay, the inverter will be invert the input. For example, the input will be 1, so the output will be 0. For example, the input is a 0, output will be 1. So that's why we will invert the input. So this one will be same as the complement. Okay, first complement. Okay, remember the first complement just invert the input. So they use the NOT gate. Okay, they use the NOT gate. For example, we have this one for AND gate. AND gate we have the 1, 1. Okay, 1, 1. The output will be 1. Alright, so this one will be we call the multiplication. Alright, for example, 1 multiplied by 1 will be 1. Okay, and then for example, another example, we have 1, 0. Okay, so 1 multiplied by 0, the output will be 0. So this is the output will be 0. Then for example, the output, the input, we have the 0 multiplied by 0. That means we have 0 here, 0 here, and then the output will be 0. Okay, so this is in terms of the digital, 1 0 1 0. Okay, but we can use this because this is only one. Okay, only one gate. But if we have combinational of lot of gate, maybe more than 10, so we have to introduce some techniques, okay, to simplify this output lah. That's why we use the Boolean. Okay, we use the Boolean algebra. That means we present the this digital in the Boolean algebra. For example, if you have input, you can A here. We set as a A. So that means the output here will be A bar, or we call the complement of A. Okay, complement of A or A bar. Alright. So for example, second, okay, for the O here, for example, the input 1 we have the A, and the input 2 we have the B. So the output here will be A plus B. Right. So this we call the Boolean algebra or Boolean expression. So this one we call the Boolean algebra or Boolean expression. That means we try to imitate the digital signal here 1 0 1 0 into the Boolean algebra. Okay, in terms of using the A, B, or you can use any character lah, any character. So for example, you can use the C, D. Right. For example, you want to use C, D or X, Y, Z, Y or something like that. So it's okay. Alright, so that means here if you use C and D, so that means the output will be C plus D. Right, so this is some revision, just basic. We go to the basic logic gates. Okay, next, and this is some revision on the logic gate. Maybe some of you already study about the logic gates on the matriculasi, maybe on the secondary school. Alright, so the learning outcome for topic number 2, chapter number 2 will be, first you have to describe the operation or basic logic gate. So that I mentioned to you, on the logic basic gate, we have 3 types of basic gate. We have the NOT gate, we have the NOT gate, we have the AND gate, and we have the OR gate lah. So this is the basic logic gate. And then we have the combination of 2 for example, like 2 or more logic gate. For example, we have the NAND gate, Null Gate, and also we have the exclusive OR, exclusive NOR. This is the combination of more than 2 logic gate lah. So, and then another one we have the universal. Okay, we call the universal gate. That means the universal gate we can use to represent for the basic logic gate. For example, we have the for the universal, we have the NAND gate and NOR gate lah. So this NAND gate and the NAND gate and NOR gate we can use to imitate the basic logic gate. For example, like OR, AND, and NOT. And then second learning outcome is a construct logic circuit from the Boolean algebra. Right. So we have the circuit. Okay. For example, we have the circuit combination of the logic gate, and then you have to get the Boolean algebra, or sometimes we call the Boolean expression. And then you have to use theorem of Boolean algebra to simplify the complex logic circuit. So that means we have to use the theorem of Boolean algebra. So here in the theorem we have the rules, and we have the law, and also we have the theorem, the Morgan Theorem, to simplify our complex logic circuit lah. For example, we have a lot of expression, Boolean expression. So how we want to simplify this Boolean expression to the simple one? So that's why we have to use the theorem of Boolean algebra. Right. Next, we have used the cannot match, or sometimes we call it K-map lah. For simplicity, I use the K-map. K is stand for cannot match, to simplify the truth table function. Right, and then use K-map to simplify the Boolean expression. That means K-map also simplify the truth table and also simplify the Boolean expression. Okay, and then utilize don't care condition to simplify logic function. Okay, so this is some learning outcome for chapter 2. Alright. So this is content lah. Alright. So today we try to cover until 2.5 lah, until the standard form of the Boolean expression. So tomorrow, okay, actually, so because of next week we don't have the class. So for tomorrow we have the class. We have the replacement for the next week class. So we do the tomorrow class. But so tomorrow our class will be start at 9 a.m. For tomorrow we will start at 9 a.m. because maybe some of for your information, we have a new student from Bangladesh. Okay, so we have the different times. Okay, that's why we have to start on 9 a.m. so that we from in the Bangladesh around 7 p.m. is okay lah. Compared when we start at 8, so that means on the Bangladesh will be 6 o'clock. So will be too early lah. That's why tomorrow we just try to finish on 1 hour because today we try to cover until 2.5 until standard form of the Boolean expression. Then tomorrow we just cover for Boolean expression and truth tables, K-maps, and designing combination logic circuits. Okay, tomorrow we have the class. So tomorrow I will remind again. Don't worry, I will remind again. So this is tomorrow class. Okay, tomorrow class we have tomorrow class. So at 9 we'll be use the Teams. Okay. So maybe 1 hour class, don't worry, 1 hour. We'll try to finish on 10 because I know some of you have the class on 10. So just finish on 10. Okay, so next we go for the introduction of the Boolean Algebra that I mentioned to you. So the digital electronic system manipulate binary information. To design such system, we need a convenient mathematical framework lah. So that's why we introduced the Boolean Algebra to provide this framework because you can see most of the system too complicated to chain in our head. For example, we have a lot of digital combination, maybe more than 10. So that's why the output we can suppose the output is easy. For example, for binary is only 1 or 0, but to get the just a 50-50%. So if you're wrong, so will be the answer is wrong lah. Because if you suppose the answer will be 1, so okay, you put the 0, so the totally your result will be wrong lah. That's why we try to introduce one technique that we call the Boolean Algebra, so that we get provide the good result lah for the output. Okay, so the Boolean Algebra can be used as the design tool for digital electronic circuit lah. Alright, so this one I just skip this one. So you can see this one. Alright, so we can use the symbol to represent the Boolean variable that I mentioned to you. So we can use the single character. For example, we can use the A, B, or any character lah. And then normally we use the upper character. For example, the upper letter for A, B, and then for example, like we have the Nand Gate here. Okay, so we Nand Gate here. So we can declare this one as the 1. This is A and this is a B. So the output here will be A dot multiplied by B lah. Or we can write like this, A dot B. Okay, the both is correct. So you can write like this or you can write like this. Okay. So this is we call that I will mention to you. So this is we call the Boolean Algebra lah, or Boolean expression. So for another example, we have the OR here. So maybe C X, for example. So the output we can declare as the Y. So the output Y is the C plus X. Okay, so this is we call the Boolean variable lah. Okay, Boolean Algebra. To express the input and output. Okay, this is for input and this is for output lah. Right, so this we call the Boolean expression or Boolean Algebra lah. Okay, so this is some example. You can see this example here. Alright, for example, we have 3 variables. Okay, you can declare any variable here. So for example, here you declare as the L as the lamp. Okay, L is the lamp. S for the sensor. Okay, for the sensor, like sensor here. And M is the switch or manual switch. Okay, so you can see this one. So lamp will be on when either one. Okay, either one will be trigger, or will be active lah, or will be 1. That's why we use the so this is the we call the Boolean expression, Boolean expression. Similar like I explained before this. So maybe so this one is declared as the M, and M is the is the represent as the sensor, light sensor, and M represent the switch, okay, manual switch, and then L will be lamp lah, represent as the lamp. So you can see this one, so if lamp is on, that means either one lah. For example, we have this one 0, 1. Okay, so for example, the light is not on, okay, it's not active, but M is active, so automatically the lamp will be on. Okay, for example, we have the input 1, 1, so automatically lamp will be on. Okay, for example 0, 1, 0, so automatically L will be on. Okay, but if we have the 0, 0 here, automatically lamp will be 0. Okay, that means lamp will be off. So this one we represent as the Boolean algebra lah, to describe the logic. Okay, so this is a basic Boolean operator or logic gate that I mentioned to you. So this is actually is a basic lah. So we have the inverter, or sometimes we call it not gate. Okay, we have the AND gate, we have the OR gate, and then the exclusive OR gate is the combination between the two OR gates, and then this one for NAND gate we have the combination between the AND and NOT gate, and also for NOR gate we have the combination between the OR gate and NOT gate, and also so on. So this one is combination and then normally NAND gate and NOR gate is the we call the universal lah. Okay, universal gate. So universal, that means so from this NAND gate or OR gate we can produce the OR gate, AND gate, and NOT gate lah. So that's why we call the universal. So this universal we can use to represent another gate lah, another gate. For example, for AND gate, for OR gate, or sometimes you can also emit it for the exclusive or exclusive NOR. So that's why we call the universal gate. That means universal gate that can represent for other logic gate lah. Okay, so this one is so on the basic logic gate we have symbol. Okay, we have the symbol, operation, truth table, mathematical expression, and timing diagram lah, that you have to know. So for example, this is a symbol for AND gate, for example. This one we call the AND gate. Okay, this one is the symbol for NOT. Okay, NOT gate. And then another one is the this one is the OR gate. Alright, so this is symbol operation, as you know. So normally operation we can draw in the truth table lah. We can draw into table. For example, like I will show after this. You can put on the truth table, and also you can put on the mathematical expression, and also you can display as the timing diagram lah. Okay, so we go one by one. So on the first we go for the inverter or NOT gate. Right, so you can see this one. The operation is NOT gate reverse the input. That means invert the input lah. That's why we call the inverter. Invert the input. For example, input 1, the output will be 0. If the input is a 0, the output will be 1. Right, but in the mathematicals, okay, in the Boolean expression, so for example, the input is A, so the output will be A bar. Alright, so this one. So this is we call the Boolean expression for mathematical expression for NOT gate. And then this is we call the truth table. So we do some of the possibility of the input and output. For example, input A is a 0, that means the output will be 1. So the input is the 1, so the output will be 0. That's for the NOT gate. Right, you can see the timing diagram. So this is the input, and then this is the output. Okay, so for example, we have the 0, 1, 0, 1, 0. Okay, that's why here we invert the input. So this one will be 1, 0, 1, 0, 1. Okay, so this is the output for the inverter. Okay, for example, if we have the figure, we have the graph here. For example, this is a graph for A. Okay, graph for A, and then for example, we have the one here is 0, and then if we have the complement of A, that means, or we have the inverter of A, so the output will be like this. Alright. Okay, so this one we call the A bar or complement of A. That means we invert the input. This one can 0, make sure this one 0, so invert the input will be 1. That's why we get here 1. Okay, this one will be like this. So this is the, for example, if you have the graphical, this one in the timing diagram in the digital, in the digital electronic. So this is some example on the diagram on the graphical. Okay, so this is a application. You can see the application that we use the NOT gate on the first complement. So we use the first complement using the inverter here. Okay, maybe just remember for the last class. So we have the first complement, second complement. Okay, the first complement we just use the inverter lah. It means invert the input. So input 1, so automatically the output will be 0. Okay, this one input 1, so output will be 0. 0 will be 1. 1 will be 0, okay, 0 will be 1, and so on. Okay, that's why they use the NOT gate here. Okay, so this some application application on the using the NOT gate, and then we have the here we have the AND gate. Okay, next we go for the AND gate. So AND gate means both condition must be true in order for conclusion to be true. Okay, the input can be more than 2 lah. Right, this is you can see the symbol, the symbol for AND gate that I mentioned to you. Right, so this is we call the Boolean expression or mathematical expression. Right, so for example, we have any, okay, we have another one here. For example, we have another one here. So maybe we can declare as the C. So the output y is the equal to A, B, C. Or you can write like this, A, C, B. Okay, or you can write like this, C, A, B. All will be correct answer. Don't worry, it will be correct answer. Okay, this is a truth table that you have to know. For example, this D normally is we call the multiplication. Okay, for example, for if you refer to the truth table, you put the multiplication. Multiply, 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 multiply. So for example, input A is 0, input B is a 0. That means 0 multiplied by 0. So the result will be 0 lah. Okay, 0 multiplied by 1. So the output will be 0. Okay, and then 1 multiplied by 0, the output will be 0. 1 multiplied by 1 will be 1. Okay, that's why you can see this one. Actually, you can write like this. A dot is represent as the multiplication. Multiply. Okay, it's the multiplication multiply. So this means A dot B dot C, for example. So normally we can ignore lah. We can write like this. A, B, C. That means we know A multiplied by B multiplied by C. Okay, that is the process of the truth table lah. Okay, the truth table. So this is a possibility on the input, and input A for A and B, and then this is the output lah. Okay, then this is that's for the AND gate. AND gate. Okay, so this is timing diagram lah. Alright, so you can see the timing diagram. So it's multiply. So for example, 0 multiplied by 0 will be 0. Okay, 1 multiplied by 1 will be 1. Okay, 0 multiplied by 1 will be 0. 1 multiplied by 1 will be 1. 1 multiplied by 0 will be 0. And then 0 multiplied by 0 will be 0. So this is a timing diagram lah. This one, this is for output. Output for X in the timing diagram lah. Okay, that means the output also can represent as the timing diagram lah. Okay. Next, we go for the OR gates. Alright, okay, you can see the symbol here. So this is a symbol for OR gate. So the operation of the OR gate is the add lah. We have to add. Okay, we have to add. Alright, so you can see on the mathematical or Boolean expression. Okay, the output here will be A plus B. For example, we have another one here. For example, we have C, or we have C lah. Then the output will be plus C. Or you can write like this: A plus C plus D, or A C plus A plus D, for example, like this. Okay, the both is a all these answer will be correct answer. Okay, will be correct answer lah. Okay, and then this is a truth table. So for example, 0 plus 0 will be 0. Okay, 1 plus 0 plus 1 will be 1. 1 plus 1 will be 1, and then 1 plus 1 will be 1 lah. So this is we call the OR get. OR get. So that means the OR get is the, if either 1 is the true, then that means the output will be true. Okay, you can see this one. Either 1 is the true, is a 1, 1, 1. So that means our output will be true lah. So that is we call the OR get. Okay, that is the OR get lah. Okay, so this is a timing diagram. Alright, so you can see this is timing diagram. That means you, okay, for example, we have 0, 0, so it will be 0. 1 plus 1 will be 1. 0 plus 1 will be 1. 0 plus 0 is 0. 1 plus 0 will be 1. Okay, 1. And then 0 plus 0 will be 0 here. So this is timing diagram for the OR. Okay, you can see this is some application. I think this is new slide. If you are refer to the on the slide, the old version, so no application on the OR gate lah. So this is related to your assignment. So you give some application, so you have to design the logic gate lah. The logic gate on based on the application given to you. So for example, for application of the OR gate, you can see, so we have the alarm system activate when one of the window or door in the room is opening. So that means either one will be trigger or will be true. So the alarm will be activate either one. That means we can use the OR gate. Either one active, so the alarm will be active. So that's why you can see the truth table lah. So for example, we have we can declare any here. A, B, C. Alright, so we have the truth table here, A, B, C. So we have 0, 0, 0, 0, 0, 1, 0, 1, 2, 0, 1, 1, 0, 0, 0, 1, 2. Okay. Okay, so and then for example, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8. Okay, we have 8 possibility lah. Possibility, you can see go X. So this one will be X lah. So either one, that means here will be 0, 1, 1, 1, 1, 1, 1, 1, 1. Okay, so either one active, so the alarm will be activate. Okay, there is some application that we can use the OR gate. Either one lah. For example, we have a lot of input, so maybe we have 10 until 10 input here, 10 input. So until 10. Okay, for example, is our window in our house, maybe too many windows, so maybe we have 10 window or 2 door, for example. So either one will be on, so automatically alarm will be on, alarm will be triggered. Okay, only one we have the active, so the rest will be that means the alarm will be triggered. Okay, if all is not active, this means alarm is not triggered. It's not triggered. Either one, if we have 46, okay, for example, 46 or 50 inputs, if we have only one input is the true, that means the alarm will be triggered. Okay, there is some application application, for example, intrusion detection system using the OR gate. Alright, so next we go for the Nand gate. Alright, as you can see, Nand gate is the combination between the AND gate and inverter. Right, so you can see the symbol for Nand gate. Actually, the Nand gate like this. So you can see, so that's why you can start on the Nand. So for AND, so and then combine with NOT. Okay, combine with NOT gate. So that's why it will be like this. The symbol will be like this. Okay, make sure. So you have to write like this. But if you draw like this, so for example, this some example. Okay, you put the bubble here. So this is wrong. So this is wrong. Suppose like this. Okay, that's first you have to go for AND gate, then you have the inverter. Okay, so that is correct for Nand Gate. It's not come like this. Okay, so this one is wrong. So this one will be wrong answer. Okay, that's why you have to remember. So first come with come with AND gate, then followed by inverter. That's why you can see first AND gate, then followed by inverter. So this is the, you can see the mathematical expression. That means if you are put here A, B, okay, so this one will be A, B, and then this one will invert A and B. Invert A and B. Alright, so this one you have to make sure so you cannot go like this. It's wrong. This is wrong. You put like this, A dot B. You can put like this, different complement, different bar. So this one will be wrong. Okay, make sure. So this one will be okay in one bar. Will be share bar. Will be share bar. It's not separate bar. So if you write like this, so the answer will be wrong. Okay, normally if you do like this, so maybe the output will be different. Okay, the difference will be different right? For example, if you put this one, okay, I will show. If you put like this, the bar, okay, so you can see the output. So you put A, B. Okay, this one will be A bar, this one B bar. All right, so we output here because Y, so it will be A bar, B bar. All right, so this one will be different with this one. Okay, not sure. So that's why the answer will be wrong. The answer will be wrong. Make sure you have to put the correct symbol Okay, for example, you have to put the bubble in front of the AND gate here, because of the NAND gate is the AND gate followed by inverter. Okay, make sure. So this one is some mistake So and then you have to write the for example, if you put this one A bar, B bar, so it's not share. Not share. Okay, that means will be like this. Okay, so the A bar will be like this. If you do like this, okay, this is correct because you just invert the both. Okay, you invert the A and B. That's why the answer will be A and B bar. Okay, will be share. Will be share. Or for example, if you have three, yeah. For example, we have the A, B, C. So the output here will be A, B, C. Then the invert will be A, B, C bar. Okay, that means A, B, C bar will be share the same bar. Or we can say as they share the same bar here. We share one. You cannot separate like A bar, B bar, C bar. So this one will be wrong answer. Okay, make sure. So this one is the simple mistake that happened on the previous student. That's why for this class, make sure don't do the same mistake Okay, for example, you have the bar here, so make sure you have to write like this. Will be share. Okay, because of the input from this one will be A multiplied by B multiplied by C. Then invert all the input here. All the input here will be A, B, C bar semua. Bar all the inputs, not bar separately. A bar, B bar, C bar. So will be different answer Okay, so this is timing diagram. Alright, so you can refer on the truth table Okay, this one the truth table. For example, if similar like okay, so similar like AND gate, so you have to multiply and then you invert, multiply then invert, something like this multiply then invert. Okay, for example, 0 multiplied by 0 will be 0 here, so invert will be 1. All right, so that's the output will be 1. Okay, and then 0 multiplied by 1 is the 0, then invert 0 will be 1. Okay, and then multiply 0, 1 multiplied by 0, so will be 0 here, invert will be 1. Okay, this is a truth table the truth table for NAND gate. Then from this truth table you can get the timing diagram timing diagram for the NAND gate. So you can see the NAND gate equivalent operation or the negative OR gate Okay, equivalent lah. So you can use also negative OR gate. That means so this one will be inverter first, then go for OR gate. Okay, will be equivalent, but it's not equivalent with yeah, I will show this it's not the Nand Gate. So this not equivalent to Nand Gate lah. Alright, so Nand Gate equivalent to negative OR gate. Okay, so this is some application of the Nand Gates. You can see this one. If the tank A and tank B are above 1/4 full, so the green LED is on. Okay, you can refer the figure here. So this is 1/4 here. So maybe we have the sensor here. Alright, so if both detect more than this level, so the green light is on. The green light is on. If one of the tank lower or below than 1/4, so the red LED will be on. Okay, for example, like figure B. So we have tank B is the lower than sensor. This one, we have the sensor is lower than sensor, so will be the red LED will be on, will be triggered. So that's why this is some example application of the Nand Gate. Alright, so next we go for the NOR gate. For the NOR gate, okay, the NOR gate is the combination between OR followed by inverter. So similar like Nand Gate. So we have the OR gate first, then we have the inverter. Okay, will be same. Right, so that's why the output first you have to, for example, we have the X, Y. We have X, Y here. Okay, so the output will be X plus Y here. And then invert the whole thing. So that means X plus Y inverts. Okay, bar. That means X plus Y bar. Okay, all. You cannot write like this: A bar, X bar plus Y bar. Okay, so this one will be wrong answer. Okay, make sure. So don't separate the bar here. So it will be same bar. So this one will be different if you design the circuit. So it will be different with this one. Okay, make sure. So this is wrong. So if this one make the inverter will be like this. Okay, in front of this one, inverter. First you invert the X and Y, then you can plus. So this is the you can see it's a different on the NOR gate lah. NOR gate. So make sure you have to put the correct bubble lah. Okay, for the NOR gate and Nand Gate. So bubble is in front here. Okay, actually it's a come from OR gate, then followed by NOT gate. Okay, or inverter gate. Okay, so this is a mathematical expression or Boolean expression for NOR gate. A plus B bar. This one is not separate bar. You can see it will be same bar, shares the same bar using one bar here, right? Okay, so this is a truth table. Truth table for the NOR gate. So you can see if we have the 0, 0, you mean the output will be 1. All right. So first you have to plus lah. Okay, 0 plus 0, 0 plus 0 will be 0. Invert the input 0 will be 1. So the rest will be 0. Okay, so this is a truth table lah. Truth table for the NOR gates. All right, and then this is a similar lah. It's a timing diagram based on the truth table. So for example, the rest will be 0 until we get the 0, 0 lah. 0, 0, the output will be 1. So 0, 0, you have to 0, 0, the output will be 1. The rest will be 0. So you can see on the timing diagram, which one the 1, this one, this one 0, 0. This one 1, this one 0, 1, 1, 0, 0, 0. So that's why you can see here, and here will be 1. The rest will be because it's not 1, 1. So the rest will be 0. Okay, you can see this one. So this is the timing diagram. Timing diagram for the NOR gate. Okay, so you can see this one. The equivalent for NOR gate is the negative AND gate. Okay, so this is the equivalent for NOR gates. Okay, so we go for the some application of the Null Gate. You can see this is a aircraft monitoring system. So when the green LED turn on, if all the three gears are properly extended when the gear down switch has been activated in preparation for the landing. So this means all the three gears are properly extended. Okay, that means all the extended will be low lah. That means will be zero. All the thing will be zero lah. Extended will be low. That means the input one gear 1, gear 2, gear 3 here. Alright, so will be low. That means will be 0, 0, 0. Then will be green light will be on lah. Okay, if red LED turn on, if any of the gear fail to extend properly prior to landing. That means if we have gear gear this one 2 is the still high, so will be red. Okay, will be red LED will be trigger lah, will be on. Okay. So this some application that we use for Null Gate lah. Null Gate so we use on the aircraft monitoring system. So this some example application for the Null Gate. And then next we go the exclusive OR. Okay, that means we have the combination between two OR gates. Okay, that's why we have something like this. So this is combination lah. The OR gate 1, OR gate here. So will be like this for example. Okay, I'll draw again. So for example like this. Alright. Okay, so this is sorry, some what is okay. Alright, like this. Okay, so this is some example of the combination between two OR gate lah. That's why we call the exclusive OR gate. Right. So you can see the mathematical expression or Boolean expression A B bar plus A bar B. Right. So that's why this is not share. Okay, that means A, we have different bar here, and then plus A bar B. Different. So no share is the bar. So this is the mathematical expression or Boolean expression for exclusive OR. Right. So this is a true table lah. If you can see the XOR works such as the output is true if the two logic input are opposite. That means if opposite value, so will be trigger will be on, will be active, will be 1. That's why you can see. So this is a same. Okay, the input will be same, so will be false. Okay, that means it's not it's the 0. Okay, for example, this is the same, so will be 0. If difference, okay, so will be the output will be 1. Okay, if difference. Okay, next we go for timing diagram. Okay, for different. Okay, so this one will be 0, this one will be 1, this one will be 0, this one will be 1. So that's why you can see 0, 1, 0, 1. So different, the same input will be 0. Okay, will be difference input will be 1. 1 same. Okay, will be 0. Difference input will be 1. So and then you can draw the timing diagram. So this is timing diagram for exclusive OR. Okay, so we go for the some application of the XOR gates. Okay, so this is a filler monitoring system. Okay, you can see as long as both circuit A and B are operating properly, the output of both circuit are always the same. Okay, that's means so if one of the circuit fails, the input will be at the opposite level. So this condition produce high signal on the XOR outputs. Okay, so this is the filler monitoring lah. Okay, as long as the circuit A and circuit B operating properly, the output of the circuit always same lah, always same. And then if one fail, that means the output will be opposite level lah, So will be indicate the filler, at the one okay, at the one fail, so the system will be indicate the filler lah. So that's why we call the Taylor monitoring system. So that's why some of the example we use for Taylor monitoring system for X. And then another example for application of XOR or inclusive OR. So we use the half adder lah. Okay, this is some example we use a half adder. Alright, so this one I will explain on the on the next topic for the half adder lah. So this some example we use the half adder. Okay, and then next we go the exclusive NOR. That means so this is combination between the three logic gate lah. Logic gate we have the two. Okay, we have two OR gates plus we have the AND gates. Okay, something like this. Okay, this is come from we have two OR gate, then we have the followed by inverter. Okay, so this is the combination, and then this is symbol lah. Okay, actually this is symbol for exclusive NOR gate. Exclusive NOR gate, and then you can see the mathematical expression. Okay, A multiplied by B plus A bar B bar. Alright, so you can see so this one will be split. Okay, this is a split bar. Okay, it's not the it's the same bar, so it's a split bar lah. It's okay, not like this A B bar. Okay, you can see read like this A B bar. Compare this one A bar B bar. Okay, A bar B bar. This one A B bar. Okay, share. This one will be share bar. So this one will be not share. So this one will be A bar and B bar. So this is not same. So this one is not same with A bar B bar. So that I explained before this lah. So it's not same lah. So don't write like for example this one for mathematical for exclusive. Don't write like this. Okay, it's a wrong answer. Okay, you have to write like A bar B bar. Okay, and then this is a truth table lah. Truth table for exclusive. Okay, exclusive NOR. You can see if we have the same input, then the output will be true. Okay, so for example we have 0 0 is the same. We have the same input, that means the output will be 1. It's a true. Okay, and then if not same, so the output will be 0. If we have 1 1 here, so the output will be 1. Okay, if this one, if we have two input is the same. Okay, same value lah, same value, so the output will be true lah, will be true. Okay, then the rest will be 0. For example, if not is different value, so the output will be 0 or false. We call the false lah, or 0. Okay, so this one will be okay, timing diagram lah. Based on the timing based on the truth table, you can write lah. For example, we have here, right? For example, 0 1, so typically you can 0. Okay, 1 1 1. Okay, for example, we have 0 0 0 0. Okay, S 0 1 0 0. So this one we get 1. Okay, 0 0 and 1 1 will be 1. Okay, will be 1 here. So if different value, so this one 1 0, so automatically got the 0 here. So this is a timing diagram lah. Timing diagram for the exclusive NOR. Alright. So next we go for the Boolean expression of the combinational logic circuit. So before this we go logic by logic, one by one logic. So now for example, we have combination more than one logic gate lah, more than one logic gate. So you have to know that describe the logic algebra. Okay, and then implementing circuit from the Boolean expression, and then determining logic output of Boolean algebra and or logic circuit according to the inputs. Okay, for example, this one. Okay, I will show the output first. First, we have this we call the logic circuit. Logic circuit, we have the combination between the 1, 2, 3, 4 logic gate. We have the AND gate, we have the OR gate, we have the inverter, and also we have the OR gate. Alright, so we have to get the output for X here. So as you know, so this one, the output here you can write as the A B. Okay, A B. This one A plus C. A plus C. So this one will be A, B, bar. Alright. And then this one here will be A plus C. So automatically A, B bar plus C plus A plus C. Okay. So this is the answer for the output X. Alright. So this is some example how you get there, how you to find the Boolean expression. Okay, you can write like this. Okay, it's the same like this. Alright, so make sure so do the step by step lah. For example, this is a Nand Gate. Okay, the output here will be A dot B, and then this one A plus C. Okay, so this is inverter. Okay, not okay. This one make sure it's not separate bar. It's same bar. Okay, share same bar here. Alright, so it's not separate. If you write like this, so this is a correct. S is a incorrect answer. It's a wrong answer. Okay, next you can try here. So the output for the here will be A bar. A bar, this one, okay, this one will be B, right? And okay, this one will be B bar. Okay, so bring here, so A bar, okay, B, so only A bar. Okay, and then this one will be B bar, and then the output here will be A bar B plus B bar. Okay, so this is the Boolean expression for the output X. So that's why we just simplified using the Boolean expression. For example, if you put here 1, okay, this we put the 0 here. For example, so okay, cancel out this one. Okay, cancel out this one. Alright, so this one, if you put here 1, so this one will be 0, and then this one will be 0. Okay, this one will be 0. This one will be 1. Okay, this one will be 1. So 1 plus 0 will be, the output will be 1. Alright. So it's quite tough. This one, this is possibility to do a wrong answer will be higher lah. 50-50. So if put 0, okay, will be wrong. Okay, if put 1, it's correct. That's why we try to implement some technique that we can, for example, this is only, we have 1, 2, 3, 4. Okay, we have only 4 digits. Okay, only 4 logic gate. But if you have more than 100, okay, more than 100 logic gate, that's why we try to introduce one techniques that we call the Boolean algebra atau Boolean expression in terms of character. For example, like this A bar B plus B. Okay, so this one to easier to do to avoid some mistake on the output. Okay. Alright, so this is another example. Already give the answer here. For example, this one A, we have the A bar here, A bar here. So this one we have B, and this one will be C. So make sure A bar B C. Alright, this one, and then this bring okay, this is A, so this is A, and then D. So this one will be A plus D. Right, so here will be invert lah. A plus D bar. Okay, will be share. We share bar, and it's not separate bar. This bar, okay, and then this multiply lah. So A bar B C multiplied by A D A plus D bar. Right, so this is the answer lah for this one. Okay, need also have the answer lah. You can try this one. So I think this is straightforward lah. For all, just from this one A B. So we know this one will be A plus B. Okay, A plus B. Then this one will be C. Bring C here, and then this one will be D, and this one will be E. Alright, so here we have N. N we have to multiply lah. A plus B A dot C. So you can also write like this A plus B dot C. Alright. And then this one will be invert. Okay. And then this one will be invert lah. Invert all. You cannot separate like A plus B. Okay. So this one will be wrong answer. Okay. Make sure like this. It will be share the same bar. Okay. Share the same bar. Because of from this input, we invert all the input here. It's not separate input. That's why we have to share same bar here. Alright. So and then this one will be add lah. So because of the all, we have to add. So the last will be this is the answer lah. Okay, this one, for example, we have the circuit. Okay, we have the circuit. We have to find the Boolean expression. Now we have the Boolean expression. We have to draw the circuit. Okay, so for example, like this. Okay, we have the we give the Boolean expression. Okay, we have the Boolean expression. How you design the logic circuit lah. Okay, this one for this is my technique lah. Maybe you can if you can start from this one lah. Up to you. For me, normally I reverse engineering. I reverse from the output to the input. Okay, for example, from the if you have the Boolean expression here, so normally I do from the output to the input. For example, I just draw the here a b bar plus ac plus d. So we know the output will be we have the OR gate here, OR gate here. So this one we can separate a bar b, a b bar. Okay, this one will be AC. This one, another one will be D. Right. Okay, so now we can next we go for the A B bar. So that's why we have the inverter here. Okay, this one will be A B. Alright, A B. So A B, now we have the AND gate. AND gate here. So that's why here will be A and this one will be B. Okay, and then this one we have A and C. So we have the AND gate here. Alright, so this one we just share. You can share here from A, and then we introduce another one C. Okay, another character here C. And then this one D lah. Okay, you can write like this is a D. Okay, you can see it's the same like this. So for me, normally I just from the output to the input. If you have the Boolean expression, you have to draw the circuit lah. For me, normally I use from the output to the input lah. If you have the circuit, so from the input to the output, but you have the Boolean expression, you have to do from output to the input. It's a simplicity, but you can also directly. But if you already know, so you know this one A B. So we have A, B, C, D. We have four. We have A, we have B, we have C, we have D. So automatically, so A and B. So we have the okay. First we have the AND gate here. All right. So we have AND gate here. So will be A B. Okay, A and B. So we have another bar here. All right. So now we A B bar. Okay. So this one next we have here we have the A and C. So just bring share here A, and then bring C here. So this is N. All right. So this one will be A C. So go here A C. Then it's a D. So directly from the D. All right. So this one we call the here AC. This one D. So and then last we have the add. So we have the OR gate here. So you can share. So that's something like this. Okay. So that's the output for example for Y. Okay. Y is the this one. So up to you which one you are familiar. For me, normally I just use the from the output to the input. Also, you can do from the input to the output. Okay, up to you. Okay, for example, with this one, okay, this one. Okay, so we know we have the OR here. Okay, so this one will be another one, and then this one another one. That's why we start from the output. So this one will be output here, and then we split by 2. We have the A, B, C, D. So this one another one A. Right. So then this one only one. We have only one character, so you can bring to the front. But this one we have multiply this one. We have multiply this one, the both. So that's why we have another N here. N here. Alright. So this one we have another N here. Another N here. So this one will be another N here. Alright. So this one will be A, and another one we can B. So this one will be A B. Okay, so this one C, and this one D. C D. Alright, so that's why we can get C D here. So this one A, you can share here. Bring from A to here. Alright, so that's why here. Or you can start from the input lah. So we know we have the A B C D. Okay, this one will be same with this one. We can share. Okay, we have A B C, D. So you can bring lah, to bring from input to the output. Okay, up to you lah. For me, normally if I get the Boolean expression, I do reverse lah. That means from the output to the input. Okay. Also, you can do answer from the input to the output lah. It's okay. Up to you. Which one you are familiar or you want easy to understand. Okay. For example, like this. Okay, we get like this. So we know this is operation multiply. So this one and this one. Okay, this one and this one. That's why we introduce Nand Gate here. Nand Gate here we separate lah. So this one will be A plus B, and this one will be B bar plus C. So we have the here we have the OR. We have the OR gate lah, because of the output here will be A plus B. So that's why we have OR gate here. So this one A and this one B. And then this one also we have the OR gate. We have OR gate here. Alright, so will be B bar and C. Okay, and the B bar we have to come from the inverter lah. That's why B go for the inverter. Alright, and then this is a C lah. Okay, so that's why you can get here B bar plus C. Okay, and then this is the output. Okay. Okay, so this is another example that you have to try lah. So that's why in our slide we have a lot of examples so that you can easy to understand for this subject lah. It's not this topic is not tough lah. It's a simple one, but you have to make sure you understand lah. That's why we give a lot of example in our slide. That's why maybe I can skip. Maybe I explain on the example 1, 2, 3. Okay, this one you can try lah. Okay, for example, we have the example 4. We have this operation and this operation lah. Okay, so that's why you have N here. For me, normally, that I mentioned to you, I do from the output to the input. If we have the logic expression, okay, logic expression. But if you have from the logic expression to draw the circuit, I start from this one. Start from the input to the output. Okay, so this is some example. If you give the value okay, value for A is a 0, 1 is the B is a 1, C is 1. Okay, for example, from this one, we can ignore this one first. Okay, we can get the Boolean expression or Boolean mathematical expression for this one. So this one will be A bar. Okay, this one will be C. Alright, so the output here will be A bar C BC. Alright, bring here A bar BC. Okay, this one. Okay, this one will be A. Alright, so this one will be D. Okay, this one A plus D. Right, so this one A plus D bar. Okay, and then this multiply lah. So A bar B C multiply A plus D bar. Okay, so this is the output. Also from this one you can substitute the value lah. Okay, for example, A bar. What is the A bar? Okay, A bar A is a 0, so bar will be 1. Okay, B is 1. Alright, C is 1. Okay. Okay, this one will be 1. Okay, right. A is 0. Okay, plus D is a 1. Okay, this is a 1 plus 0 is 1. Invert is a 0. Okay, it's a 0. So 1 multiplied by 0. 1 multiplied by 0. So that's why the output is 0. Okay, you can do like this. Okay, you can get the final expression, mathematical expression. Then you can substitute the value, something like this. Also can, up to you. Or you can straightforward from this one. Okay, just substitute the value lah. For example, A is a 0, 1, 1, 1. Okay, and then you can get the. Okay, for example, this one will be 1. Okay, and then this one 1, 1. So this one 1, 1 will be 1, for example. At the end, you can get the output will be 0. Okay, that is another technique lah. That's why you can get from this one, from the final Boolean expression. Then you can substitute the value, or you can substitute the value from the early stage lah. Okay, from this one. Okay. Next, we go for the theorem for Boolean algebra. Okay, for this subchapter, we are focused on simplification of Boolean expression. So you can see, so for example, like this, we have okay, so maybe you can see like this. So we have the maybe so is we can actually this one we can simplify until we can get the simple one. Okay, this one is maybe it's a we call the long expression long expression. Then we can simplify this. Okay, this for example this Boolean expression using the we can use the rules or we can use the law or we can use the De Morgan theorem lah. So on the theorem Boolean algebra we consist of rules and law, and another one is the De Morgan. So for De Morgan we have the De Morgan theorem 1 and De Morgan theorem 2 lah. Okay, for the rules or for the law we have 12 rules here. Okay, you can see here 12 rules, right? So this one no need to memorize. So normally on the final exam or for the midterm we are given this table lah. We are also given this table. No need to memorize this formula because this one normally we given for the midterm and for the final normally. Okay, you can see this one. For example, rule number 1. Okay, this one we have 12 rules. That's why no need to memorize, but you have to know lah. You have to know to use this one. How to simplify the Boolean expression. So for example, we have 1 plus 0 will be A. Okay, the output will be A, and then A plus 1, the output will be 1, and then A multiplied by 0, the output will be 0. A dot 1 equals to A plus A equals to A. Okay, and then A plus A bar will be 1. Okay, this you can see this one. For example, rules number 1 and 4, this one. 1 and 4 is we call the identity law, and then 2 and 3 we call the null law, and then 6 and 8 is the we call the 6 and 8 we call the inverse inverse law, and then 9 we call the double complement law. Okay, for example, if you have double complement, that means equals to A. Okay, after this you can see how they prove this one. Already all the rules they are also prove how to get this value. Okay, how to get the A here, for example, and then how to get the 1 here, or A plus A, why A plus A equals to A. So okay, so this one already after that I will show the proving. The proving, for example, for this rule number 5, A plus A, why we get A. So why not we cannot get the 2A, for example. So this is the rule that you have to know lah. And then for 10, rule number 10 is the absorption law. Okay, absorption law. That means A plus AB, automatically we get A. So you can see this one. So this one is we call the rule lah. The rules. Okay, you can see how they prove this rule. Okay, they do the step by step lah. They show this the application of the rules of the Boolean algebra. You can see the rule number 1. The rule number 1, you can see here. All right. Yeah. 1 A plus 0 will be A. So this one will be proof lah. Okay. So you can see A is 1. Another one is a 0. So automatically X is equal to 1. Okay. For example, if A is the 0, another one is a 0. So automatically X is the 0. That's why you can get the X plus 0 will be A. Okay, will be A. That's the rule lah. That's the proving of the rule. For example, you can see on the 6. Okay, sorry, the 5. Okay, A plus A equals to A. Rule number 5. Okay, so this one you can after you can check lah how they can do this one. For example, you can go for the for example here. Right. So if you have, for example, they give a if the A is the 0 and then another one is a 0, so automatically X is a 0. Okay, if A is the 1, another one is the 1, so that's why X equals to 1. That's why if A plus A equals to A, so that is the rule number 5. Okay, that means if you have the, for example, if you have B plus B, automatically we can get the B. or C plus C, so automatically the answer will be C. Okay, even like this so we have B plus B bar, so automatically 1. Okay, or C plus C bar, so automatically 1. Okay, for example this one and also rule number 7 so for example we have B BB so BB, automatically we have a B here. Alright. Okay, and then for A dot A bar will be 0, so this one will be 0. Okay, and then so on so this one how it prove the rule every rules. So you can see this one after this you can see so I just skip this one because normally we just use this rule okay, we just use this rule, and then normally this rule will be given for the midterm, for the test, so no need to memorize this formula Okay, and then we go for the law of the Boolean algebra. So we have the commutative law, we have the associative law, and distributive law. So this one, okay, that I mentioned to you so you can see this one. Before this, you can write like this: A plus B or B plus A is a same answer. Okay, if you put like this, also same. This one also same. You can change this one to this one, also can. Okay, that's why this one we call the commutative law Okay, this one will be same So for example, we have the I'll show you before this. So we have the A plus B plus C. Also, you can do you can write like this: A plus C plus A plus B. Okay, is correct or B plus A plus C. Okay, also correct. All this one will be correct answer because of this law commutative law we call it commutative law so also this one A dot B or B dot A or sometimes we call it AB or BA. Okay, this is the same. Okay, this one like this so you just change. For example, this one you put as the B, this one is the A, so you can write like this AB also correct, or you can write the BA. Okay, the both is a correct answer. This one we call the commutative law. Okay, and then associative law. All right, so similar like I explained before this. For example, we have the OR gate here. If you have the A plus B plus C, also you can write like A plus C plus A plus B, or you can write like B plus A plus C. All the Boolean expression, the Boolean algebra will be correct answer similar like this So also you can do like this: A plus B plus C or A plus B plus C. Okay, also same this one will be same. Okay, this one we call the associative law. Okay, will be similar like if the multiplication for example for multiplication, also you can do A B C, or you can write like C A B, or you can write like B A C. Okay, all the Boolean expression will be correct. Okay, will be correct answer. Then for the next is the distributive law. Distributive law also you can see this one. For example, we have the A multiplied by B plus C. Also, you can write like this: A dot B plus A dot C. It will be like this one. So A multiplied by B, A multiplied by just expand. Okay, you just expand this Boolean expression in terms of this one. A B A C, or you can write this A B A C. You can ignore the multiplication, the dots here. Also, you can write like this. Similar like this one. Also correct. Okay, this one we call the distributive law distributive law. Okay, so next we go for the De Morgan theorem. So that I mentioned to you. So we have two De Morgan theorem. We have theorem 1 and theorem 2. Okay, but the keyword that you have to remember, okay, this one you have to remember: break the bar, change the operator. Okay, the operator, that means if you have to multiply, you have to change to plus. You have the plus, you have to change to multiply. Right, so I will show an example. So break the bar. Okay, so this is theorem 1. Theorem 1, that means x plus y bar is the same. It's the share bar. Okay, it's the share one bar here. Okay, you can change this bar. Okay, you can separate this bar using the De Morgan Theorem 1. Okay, that means you break the bar, we break the bar, we separate the bar here, but we have to change the operation. Okay, that means to you from plus to multiply. So this one is the plus, so you have to multiply. So the answer will be x bar dot y bar, or you can do like this, will be same, x bar y bar. Okay, so this one is right, also this one also right. So make sure remember this one. Okay, for De Morgan you have to remember either theorem 1 or theorem 2 will be same. Okay, and so this one, for example, we have the a dot y bar is a share bar. Okay, share bar here. So the keyword you have to remember is the break. You have to break the bar, and then we have to change the operator, so from multiplication to x. Okay, so this is the a bar, x bar plus y bar lah. Okay, for example, we have the a b bar here. So here, okay, a b bar here. So we can use the De Morgan 2, the theorem 2. Theorem 2. That means a is separate by 2. Okay, but the operation before this is a multiplication, so we change to plus. Okay, this is the on the theorem 2 lah, De Morgan Theorem 2. Or we have the something like this. We have the a plus b plus c, for example, bar. Okay, a plus c, b plus c bar. So we can use the theorem 1. Theorem 1. So this one will be break the okay, we have to break the bar and then change the operator. So the break the bar, change the operator. So bar, okay, b bar, c bar. Okay, this one plus, so we change to dot, multiply, dot, so multiplication. Okay, so remember this one. For example, we have example here lah. So this is the De Morgan Theorem. Also, De Morgan Theorem used to simplify the Boolean expression. Okay, so this is the proof. The proof how the De Morgan Theorem works. Okay, this one I will skip this one. Okay, we go for the simplification using the Boolean theorem. So this one I will explain. Okay, you can see this one. So we have the, for example, we have the Boolean expression. This one. We have y equals to a b bar d plus a b bar d bar. Right. So how we can simplify this one? Alright. So that's why you can use. Okay. So this one already give the example. So we use the rules number. Okay. Rules number 5. Rule number 6. A plus b bar is equals to 1. Okay, that means here, right? A b bar. So, okay, please silence your mic. Okay, switch off your mic first. Alright, so you can see this one. So this one d. D plus d bar. Okay, so this one will be 1.
Somebody muted, Doctor. Doctor, we can't hear you.
Okay, sorry. Okay, can you hear this one? Here? Alright.
Yes, we hear you now, Doctor.
Alright, so okay, so this one I'll repeat again. So for example, we have the Boolean expression here. So how we simplify this one? How we want to simplify this one? We can use the that's why we have 12 rule, or we have the De Morgan rule. So you can use either one. So which one you can see which one you can use. For example 1. Okay, that means you can use the rule number 6. That means a plus a bar will be 1. So this one you can see this one. So I will do this again. So a bar b multiplied by d plus d bar. So this one is the same like this one. A plus A bar, so it will be 1. So this one will be 1. So that means this one A B bar multiplied by 1, so the answer will be A bar. Okay, so you can see the example of the number, okay, number 2, example 2 here. Okay, A bar plus B multiplied by A plus B. Alright, so this one you can see that we use the rules number. You can use the rule number 12 and we can use rule number 8. Okay, also you can, so for example this one, if you cannot clear this one, also you can multiply for this one, multiply this one, multiply this one, then plus this one, and then multiply this one. Also can, then you can, for example I just multiply A bar B, sorry, A bar A, so this one A bar multiplied by A, so this one actually you can use rule number 8 will be 0. I will read first. Okay, the expression of this equation, this Boolean expression, A bar multiplied by B. Okay, then plus B multiplied by A. Then last is the B multiplied by B. Okay, so you can see. So this one is a similar rules. Rule number okay, rule number 8 is a 0. Okay, you can see 0, and then this one B multiplied by B will be B. Okay, this one will be B, and then you can see this one, so you can write like this: A B plus A B. Right, so that's why this one you can use the rules, and then you can simplify. At the end, you can get the this one equals to B. Z equal to B. Okay, that's why you can check. Okay, either you can straightforward using the this one is using the explain formula for rule number 12, or you can do like this. Okay, for example, show another example here. For example, we have the this example 3. Okay, we have the A C D, okay, plus A bar B C D. Okay, which one you can simplify? So you can simplify. We have the C D here, so you can simplify here, and then we can use the rule number 11 lah. So A plus A bar B, so equals to A plus B. Okay, A plus B. So this one will be change CD plus A plus B lah. Alright, and then you can expand lah this equation, so to be like this lah, A B C, okay, C D A, or plus C D B. Okay, so will be same lah with this one. Okay, and then so example 4, okay, you can see there, example 4, A C bar plus A B C bar. So which one you can simplify? You can use the rules number 10. Okay, A plus A bar equals to A. Right. So that's why just simplify using the A and AB. A plus AB. Okay. So will be, that's why here will be maintain the A, and then this one will be C bar here. Okay, you can see this one. So we have C bar here. That's why you can get the answer is the A C bar. Okay, so this is some example how to simplify using the rules. Okay, so you can see how you can simplify using the De Morgan. I will show some example here. Okay, so for the De Morgan, how to simplify using the De Morgan. So first you have to see the upper bar here. Okay, you can see the upper bar here. So we can see here. So we have upper bar here. So the operation we have to remember, break the bar, change the operation. So we have to break here. Okay, we have to break here. So this means we have to break A plus C bar. Okay, bar. Right. So this one multiplication plus B plus D bar here. Okay. So this is a De Morgan. Okay, you can see. Next, you can see this one, this part. Second. Okay, this part. So we can break the bar. change the operator. So break the bar. So A bar dot C bar. Okay. Plus B bar dot double D bar. Okay. Okay, see this one. So A double bar will be A lah. Okay, this is familiar. So A double bar will be A. You can check the rule number. I forgot the number of rule lah. So you can check on the rules. So this one will be A double bar will be A multiplied by C bar plus B bar D. So this one will be cancel out lah. So this is the how to use the Boolean the De Morgan plus the rules lah. The rules. Okay, A double bar will be A. Okay, so these are example using the De Morgan. So for the De Morgan, make sure you solve from the upper bar here. Solve this one. So the bar here, so will be split by here as this point. So maybe I will show another example. So if you have another example for the Boolean for the De Morgan. Okay, so next you can go for example 7. So this one using the rules. Okay. Okay, I will skip this one. So you can try after this. I will go for the Boolean expression. Okay, you can see example 11 here. Okay, actually this is the same lah. I think it's a same bar. I'm not sure. So I think it's the same bar. It's the same bar. So maybe right. So the first step you can see which one the okay you can split. Right, you can split here. Okay, we can split here. So we can split here. Okay, so that means we can split. Okay, break the bar, then change the operator A bar, B bar. Okay, bar here. Right. So plus C bar plus D bar bar. Okay. So you can do after this. You can do separate lah. Okay. So maybe I solve this one first. Solve this one first. Okay. So this one I will split here. Okay, I will split here. So A bar double bar dot B double bar here. Okay. Then next I will solve this one. Plus this one will be maintained lah. This one we maintain only this part. Okay, this one sorry, this is plus. Okay, because this is multiplication, this is a plus lah. You have to change the operator. You have to change the operator. So this one will be maintained because we already changed the operator here. So this one will be C bar dot D bar. Okay. So this one A double bar will be cancelled out. B double bar will be this one will be plus. Okay, and then plus C double bar will be cancelled as C B. Okay, so this is the answer lah for this one. Right. So for the Boolean, okay, for the using the De Morgan, for De Morgan, okay. You can see for the example 12. So we have okay, we have 1 bar, 2 bar, 3 bar. So first, I mentioned to you, you can check on the upper bar here. Okay, on the upper bar here. So the operation will be split here. Okay, we will split here on this part. Right. So you can split by 2 at this point. Okay, you can see. Okay, make sure on the you have to first break the bar on the upper bar. Here on the upper bar here. So this one will be change the operation. Okay. So x plus yz bar here, and then the bar here plus. Okay, this one change to plus. Okay, so x bar yz bar. Okay, so this one you can see this one. So change break the bar here, change the operator. So break, already break here. Okay, from this one break, and then change the operator will be plus. Okay, and then you can see this one. So this one will be double bar, same bar, we can cancel out. Okay, so it will be x plus y z bar. Okay, this one can cancel out. It's similar like this. A double bar equals to A. Okay, this one cancel out. Okay, then I will solve this one next. This one. Okay, so this one will be here. We have to split here. So x double bar plus y z bar. Okay, Then we go for the next x plus, okay, so we have to split this one, x, okay, y bar plus, okay, this one multiply, you have to plus z bar, okay, and then x double bar will be x, okay, this one, okay, we can split, okay, y bar, okay, this one multiply, you have to add, okay, so z bar, okay, so that's the answer. And then you can check which one you can simplify. So this one, so for example, a plus a equals to a. Alright, so you can check on the rules, so this is the rule. That's why you just simplify x y bar, because this one can simplify and then another one can simplify. So at the end you can get this one, so this is the rule, you have to remember the rule here, so a plus a equals to a. Similar like this, x plus x equals to x, or y bar plus y bar equal to y bar, z bar equals to z bar equals to z bar here, only one here. Okay, so that's the last answer for the De Morgan. Okay, make sure okay, for the De Morgan, make sure you break the bar on the upper lah, this one, this part on the upper layer first, then go for second, then for the third, and so on lah. Make sure on the upper layer lah. So this one you focus on the upper layer for the break the bar here. Okay, this one you can see. So we can, why we can split here? So because of the second layer, based on the second layer. So on until this one, that's why you can split to this point. You can split for this point. Okay, so this is an example on the De Morgan lah. Okay, next. Next, we go for the standard form of the Boolean expression. Okay, for the Boolean expression, we have two standard form lah. First, we call the SOP. Okay, SOP here, you can see what is the SOP. And second one is the POS. POS. Okay, SOP is a sum of products form. Another one is the POS. POS is the product of sum. Okay, that is, we have two standard lah. We have two standard form on the Boolean expression. First, we call the POS. Second, we call the SOP or POS. Okay. For SOP, normally we stand for sum of product. That means sum based on the product. And then for the POS, product of sum. That means we have to multiply, then we have to plus. And then this one sum, we have to plus, then we have to multiply. Okay, that's we call the SOP, SOP. And then POS, okay, POS is product of sum. That means we have to multiply, product is we have to multiply, then we have to sum. Okay, there is two standard formula for the Boolean expression. So let's we go for the sum of product, SOP. Okay, SOP form, sum of product lah. So that's right, sum of product. Okay, you can see this is a sum of product. This is multiply. Multiply, this is multiply, or something like this. This is a sum, and then this is a multiplication. This one multiplication, this one multiplication, this one multiplication, this one multiplication, this one multiplication. Okay, can you see this one? So this is we call the sum of product. Okay, this some example lah. So we have, can write like this: A, B, D plus C, D, A, something like this. So this one we call the sum of product, SOP. Okay, but this is not standard lah. After this, I will explain how to standardize this in terms of SOP, sum of product. So, but this is a SOP form. Okay, that means sum of product. So this is a sum based on the product. This means based on the multiplication here. So that's why we call the sum of product. Okay, next. Now we go for the, okay, this one I will skip first. I will go for the POS. I will go for the POS. Okay, so POS, you can see this one. POS is the product of sum. Product of sum. That means product, this is multiplication. Okay, multiplication based on sum here. Sum, alright, so we will add here. Sum is the add lah. Okay, another example here. A plus B dot, okay, dot C plus D. So this one we call the POS. Okay, post product of sum. For example, we have x plus y multiplied by a plus b plus c multiplied by y plus a plus m. Okay, so for this example there are some example of the post. Okay, product of sum. Okay, product of sum, and then that means multiply here based on sum. Okay, this is a multiplication addition lah. You have to sum of this Boolean expression lah, x plus y. Okay, this one for example a plus b plus c and so on. Okay, this we call the post. Okay, product of sum, and another one is the sum of product. Okay, so that's why you have to remember. So on the standard form, we have two technique lah. We have two standard. First, we call the sum of products. Okay. Second one, we call the product of sum. Okay. If sum of product, okay. So this some example lah. This means we have to sum here based on the multiply. The product is the multiplication lah. Okay. So for example, we have the x, y, z plus a, b, c. Okay, plus d, e, f, g, for example. Okay, this one we call the SOP form. Okay, SOP form. Okay, this one we call the SOP form. But this one is not a standard SOP. Okay, it's not the standard form. Okay, so actually we have another one we call the standard. Okay, this one. Okay, this one is not the standard. This one is not the standard SOP, but this is the SOP form, but it's not the standard. So I will explain what is the standard SOP form. Okay, the standard SOP form is mean every component they have the same character. For example, we have the A, B, C here, right? So another one also we have the A, B, C character. Okay, so this one we call the standard. Okay, it's the standard SOP form. Okay, this one so you can see this one so we have element here, element 1 here, so we have A, B, C, and element B also we have A, B, C. So this one we call the standard. Okay, this one is the standard SOP form. Okay, for example, this one. Alright, so this one we have the X, Y, Z, but this one we don't have the X, Y, Z here. We have different character, and also this one we have the different character here. So automatically we know this is SOP. This is SOP, but it's not standard. Okay, it's not the standard. For example, this one. Okay, example number 2. So this element 1, we don't have the C, D, E, F, we don't G, K, and also H, L. You can see this one. We don't have for element 1. For element this one, A, B, we don't have C, D element. We don't have the E, F element. We don't have G, K element. We don't have the HL element. So this one we call the SOP, but it's not the standard. Okay, for example, I will show an example. A, B, C plus A bar, B bar, C bar plus A bar, B, C bar plus A, B bar, C. Okay, so you have this one. For example, this one. Okay, this one we call the standard SOP because all element we have the ABC here. So this one also we have the ABC. Okay, this one also we have the ABC, and this one we have the the ABC here. Okay, and this one we call the standard SOP form. Okay, this one is the standard SOP form. So how to for example, we have the non-standard. Okay, non-standard SOP, how to convert, I will explain after this. So for example, like we go for the post. Okay, I will show the post standard form first. Okay, all right, you can see this one. Okay, so this is a post. Okay, but this one is not a this one we call it not standard. Okay, it's not a standard post. Okay, for the standard post, for example, we have this one. We have the A, B plus B bar plus C multiplied by, we have A plus B plus C. Okay, we have the multiplied by Okay, another one here, multiply A bar plus B bar plus C bar. Okay, multiply by A plus B plus C bar. Okay, so this one, okay, we have 4. So this one we call the standard. Okay, we call the standard post. Okay, standard product of sum. Because this element we have the ABC, we have this element we have the ABC, this element we have the ABC, and also this one we have the ABC invert. Even we have the invert bar or not, is okay. So but all the product here we have the element we have the element ABC, we have the all element here, we have the ABC, we have here also we have the ABC, this one also we have the ABC. Okay, for example this one okay, this is not standard post, also this one is not standard post. Okay, for example this one, okay, this is if we have like this A B C plus C plus D. Okay, so maybe A bar plus B bar plus C plus D. Right, so this one we have the element A B C D. So this one also we have the element A B C D. So automatically we know, so this is we call the standard form. Okay, so this is a standard form lah. Okay, so that you have to remember. So we have standard form or non-standard lah. So for sum of product, so something like this. Okay. Okay, so this one so we have the odd element lah. So for example we have like something, I will show some example lah. So how to from the non-standard to do a standard format. Okay, for example this one so this we call the SOP. Okay, this is SOP form. Okay, this is SOP form. We have the sum of product. Okay, sum of product. This is a product, but this is sum. So this one we call a sum of product form, but it's not a standard SOP lah. It's not a standard. So if the standard, so this one we have the element C and D. This one we have the element. Okay, so this one you can see. So we don't have the CD, and then this one we don't have the A, and this one we don't have the B and D. Okay, clear this one So to a standard for this one, we have to, okay, you can see this one so for this element we have to add another two lah. So we have to add C and D. This one we have to add the A, and then this one we have to add B and D, so that this form will be standard form lah. So how to add? Okay, so I will show you how to add So this one we have to add CD, this one we have to add A, and this one we have to add B and D. Okay, so because all we have the all element lah. For example we have A B C D, this one also we have A B C D. Clear this one so we have one A B C D. So all element we have the A B C D. All right, so how to insert? Okay, so how to insert CD here, how to insert the A here, how to insert the B D here. Okay, so this one is the technique is a technique from non-standard form SOP form to standard so how to insert. Okay, so we have to use this. Okay, we have to use this formula. Okay, so we have to use, okay, so this one they want to insert the C, so you have to insert C plus C bar. All right, so actually this one C plus C bar is the 1 actually. Okay, it's a 1. If you multiply, so this one is a 1, right? So for example you want to substitute the value of the D, so just multiply by this one D plus D bar. Right, clear So for example if you want to substitute the value of B, for example B here, so B plus B bar. Okay, then we go for the another example here. All right, so this one, all right, I will show some how we can implement this one so we have to multiply by A, so we do not here so we have B C D multiplied by A plus A bar. Okay, so you have to multiply lah, expand so this one will be A B C D plus A bar B C D. So clear so this one automatically all we have the element A, B, C, D, and this one also we have the A, B, C, D. Yeah. Okay. For example, for this one, we have to substitute the value of the C and D. So we have the A, B. All right, A, B here, A, B here. So you can do one by one. For example, first you can do the C. Insert the C first. C plus C bar. All right, C plus C bar. All right, so A, B, C plus A, B, C bar. All right, so clear. So this one first insert the C first. Then, for example, we have the A, B, C. Here we have to multiply by D. D plus D bar. And this one A, B, C. We have the A, D plus D bar. Okay, so this one we have the A, B, C, D. Okay, this one expand. Okay, and then plus A, B, C, D bar. Okay, right, and then plus this one. So we have the here expand. Okay, this one. So we have the A, B, C bar, D plus A, B, C bar, D bar. Okay, clear. So now we have 1, 2, 3, 4. Okay, 1, 2, 3, 4, 5, 6. Okay, here. So for to this equation, right? So next you can try this one. You can try to standardize lah. That means first for AC I will multiply here. Then next you can compare lah. Which one is same? For example, this one. You can simplify. This one A, B, C, D is same with A, B, C, D. You can cancel out at the one lah. So will be maintain one. Alright. So for example AC. So I do here. So AC. So AC here. So first we don't have the B and D. So maybe you can do one by one lah. B. Okay. So this one will be A, B, C plus A, B bar C. Then we don't have the D. Okay, so multiply by D plus D bar. Okay, this one A, B bar C plus plus D plus D bar. Okay, so this one will be A, B, C, D. Right? Expand this one. Okay, plus A, B, C, D bar. Okay, plus one expand. Okay, A, B bar C, D plus A, B bar C, D bar. Okay, then you can compare lah. So this one we have, for example, we have A, B, C, D. Okay, we have cancel out. Okay, because this one we have A, B, C, D. This one also we have the A, B, C, D. Okay, A, B, C, D, and this one also we have the A, B, C, D. So you can cancel out only one lah. This means we follow the rule. For example, we have the A plus A plus A plus A equals to A lah. That's why you can, this one we maintain one lah. So the rest you can cancel out. Okay, cancel here. This one you cancel out. Okay, for example, this one cancel out, and then just maintain only one. Okay, this is we call the standard SOP form. Okay. Okay, the last one. Okay, the last one for today. For post. Okay, how to do a standard post. Okay, this one. Okay. So for example, we show some example here. Simple example lah. So this one. Okay. Maybe we have A, B. So we A plus B multiplied by C. Alright. So this one we don't have the C. Okay. This one we don't have the A and B. Okay. This one we don't. This element we don't have the C element, and this one we don't have the A and B. Okay. So this one for the post you have to remember. So how to insert? Okay. To be a standard post, so you have to multiply by this formula. Okay, this one using this formula. A multiplied by A bar, right? So you have to add this one. A multiplied by A bar, because if you simplify this one, actually it's a 0. Okay, for example, if you put here, okay, A plus B. Okay, for example, A plus C. So this one we don't have the C value. And this one we don't have the B value, B. So I will show how to insert the C here, insert the C. So we have the A plus B, okay. So you don't have the C values here. So C value is this one, this element. So how to insert this one? You just B plus C bar. Okay, you can insert like this. Clear, this one? Okay, you can see that, but you have to expand. So this one is not like this. You have to expand. So okay, actually, if you simplify this one, actually this is a 0. So it's just similar like A plus B. So this one is to do a standard lah, the standard post. So this one we can expand to be like this: A plus B plus C. Okay, multiply by A plus B plus C bar. Okay, clear this one. So we expand this one to this one, this equation. Okay, and then for this one, for example, for A plus C, we don't have the B, A plus C. Okay, so we have to plus B plus B bar. Okay, and then we have to expand A plus B, plus C plus B multiply by A plus C plus B bar. Okay, so and then so this is the standard formula. So you can see, so this you have the element A, B, C, D. We have A, B, C, A, B, C. So this one also we have the A, B, C, and also this one we have the element A, B, C. So this one we call the standard post. Okay, standard post of products. Okay, right. So that's all. We have two standard form. Okay, first is the post, and second is the SOP. So so you have to remember how to do a standard. So you have to multiply. For example, this one you have to add A plus A bar for post, and then for the SOP you have to A plus A bar. So that's the difference for the SOP and something like this. You can see. All right. So this one if you put A plus A bar, A plus A multiplied by A bar, and then we can expand like this. Okay, first A plus B plus C plus D bar, and then second is the A bar plus B bar plus C plus D. Okay, that's all. Alright, so you can see this one. So this one we want to introduce the A element inside this one, because we are missing A here. So this one, for example, this one we are missing D. So how to insert the D? So we have to add this one. Add D plus D multiplied by D bar. So actually this one, if you use the rule, actually it's a 0. Actually it's a 0. Okay, it will be 0. So actually it's the same like ABC, A B bar plus C. So it's a similar, but this is not a standard form because of this. You don't have the element of D, for example. So this one we don't have the element D, and this one we don't have the element of A. That's why we're missing A here. We're missing D. So how to do a standard? So that's why we have to insert the D here, and then this one will be insert the A here. So this one we have the all element. So this one no need. Okay, and then the last answer you have to this one multiply by this part, and then multiply by this part. So that is the last answer, this one. So this is the last answer. Alright. Okay, so you can see this one. So all we have the element A, B, C, D. Okay, the all element A, B, C, D, A, B, C, D, A, B, C, D, and also we have the A, B, C, D. Okay, right, class. Okay, so we're already almost 2 hours for today. So I will stop here. So we will continue on tomorrow. On tomorrow morning at 9. Will be same platform using the Teams. So I will try to. Okay, so this one we next we try to simplify using the K-map. Okay, I think the K-map is very simple compared than we use the rules and we use the De Morgan because of maybe you don't we cannot it's quite tough to find the which rule is related to the Boolean expression compared than using the K-map. Automatically we can simplify using the K-map. But if you use the rule, so you have to make sure. So we have the 12 rule, We have the De Morgan, so we have to make sure which one you want to use. For example, it's rule number 1 or rule number 2 or rule number 3 or rule number 4 or rule number until the 12. So that's why it's quite tough to use the rules or law or De Morgan compare them. You use the K-maps cannot map. Okay. So tomorrow we try to cover on the K-maps and try to finish on the chapter 2 lah. Right. So alright, so this is for today. So next week, tomorrow, so next week we don't have the synchronous class. Okay, next week because on the Thursday we have the holiday. Okay, we have the holiday is Melaka holiday, historical day. So we have the holiday on the Thursday. So no class. Okay, so class will be on the Friday, but I will do the asynchronous technique. So I will upload the video for the tutorial 1 part 2 lah. Okay, so that's all for today. So we'll be continue on tomorrow.